Okay students, this video is really just a crash course review of tons and tons and tons of problems, many of which have already been featured in earlier videos from Special Topics Lecture 1, and others are just additional examples of the same kind of thing. So what I'm going to do is go through these problems and just read them one at a time, and then next to the problems I'll provide links to separate videos in which I answer those exact problems or ones very similar to them. So once again, as you're working through this video, you should, hopefully by the end of this, be able to do all the kinds of problems that we're reviewing from chapters 2 through 5 of General Chemistry. Before beginning, of course, I want to start with a clever chemistry cat of the day from quickmeme.com. This one says, "I'm in a band called the Periodic Table. I play the cymbals." Haha. So once again, after this video presentation, you guys should be able to do every kind of problem that I'll review in this video presentation. That's pretty much it. Let's get started. This one says, only two isotopes of copper occur naturally, this kind and this kind, with these relative percentages. I want you to calculate the atomic weight, which is the average atomic mass of copper. Next one. The average atomic weight of copper, which has two naturally occurring isotopes, is 63.5. One of these isotopes has this atomic weight and this percent. The other isotope has an abundance of 30.9%, but we aren't given what the atomic weight is of that isotope. So I want you to figure out what the atomic mass is of the second isotope. Next question. Name each of the compounds below and give the charges of their cations and anions. Next, which formula name pair is incorrect of these different examples? Next, write the chemical formulas for the following compounds. Now this is not one that I've done before, but by this time you guys should be able to do this. Next, the formula for the compound formed between aluminum ions and phosphate ions is what? Now please keep in mind that aluminum always has a +3 charge when it's in an ionic compound, and phosphate, well, that's one of those polyatomic anions that you should have memorized by this time. Next, what is the mass in grams of 1 mole of carbon-12? Next, how many carbon atoms are present in a mole of carbon-12? And last, calculate the number of nitrogen atoms in 0.41 moles of NH3 or ammonia. Next, 1 mole of blank contains the largest number of atoms. Next, a 30.5 gram sample of glucose, whose formula is given here, contains how many atoms of carbon? Next, the formula weight of potassium dichromate is how many AMU? Next, calculate the mass in grams of 0.105 moles of sucrose. Next, calculate the number of moles of zinc nitrate in 143.5 grams of zinc nitrate. Now I haven't done these exact examples here, but by this time you should be able to do them, so I'll let you do that on your own. Next, determine the empirical formulas of the compounds with the following mass compositions. Next, what is the empirical formula of a compound that contains 27% sulfur, 13.4% oxygen, and 59.6% chlorine by mass? Next, what is the empirical formula of a compound that contains this percent of sodium, this percent of sulfur, and this percent of oxygen by mass? Next, balance the following equations. Next, when the following equation is balanced, the coefficients are what? Next, write balanced net ionic equations for the reactions that occur in each of the following cases. Then identify the spectator ion or ions in each reaction. Next, the net ionic equation for forming an aqueous solution of nickel iodide accompanied by the evolution of CO2 gas by mixing of nickel carbonate and aqueous hydroiodic acid is what? I'll tell you what it is. It's a very long sentence to say, but anyway, I'll leave this up to you to solve. Next, the net ionic equation for forming an aqueous solution of aluminum nitrate by mixing solid aluminum hydroxide and aqueous nitric acid is what? Next, what volume of this concentration of perchloric acid solution is needed to neutralize 50 mL of this concentration of sodium hydroxide? And separately, what volume of this concentration of HCl is needed to neutralize 2.87 grams of magnesium hydroxide? Next, what volume in milliliters of this concentration of sodium hydroxide is required to neutralize 13.7 milliliters of this concentration of HCl? Next, What volume in milliliters of this concentration of perchloric acid can be neutralized with 115 milliliters of 0.244 molar sodium hydroxide? And next, when benzene, shown here, reacts with bromine, shown here, bromobenzene, this thingy right here, is made. When 30 grams of benzene react with excess bromine, what's the theoretical yield of bromobenzene? Separately, when 20 grams of bromine react with excess benzene, what's the theoretical yield of HBr? Next, aluminum hydroxide reacts with sulfuric acid according to this equation. Which is the limiting reactant when 0.5 moles of aluminum hydroxide and 0.5 moles of sulfuric acid are allowed to react? How many moles of aluminum sulfate can form under these conditions? And separately, how many moles of the excess reactant remain after the reaction has gone to completion? Next, sulfur and oxygen react to produce sulfur trioxide according to this reaction, which is not balanced. In a particular experiment, 7.9 grams of sulfur trioxide are made by reacting 5 grams of O2 with 6 grams of sulfur. What is the percent yield of the sulfur trioxide in this experiment? Next, propane, as formula is shown here, reacts with oxygen in the air to produce carbon dioxide and water. And incidentally, the equation isn't shown here, so you have to be able to write out that equation and balance it. In a particular experiment, 38 grams of carbon dioxide are made from the reaction of 22.05 grams of propane with excess oxygen. What is the percent yield in this reaction? Incidentally, it tells you that the oxygen is in excess, so you know that the limiting reactant is your propane. Next, how many kJs of heat are needed to raise a temperature of 10 kilograms of liquid water from this temperature to that temperature? Please remember the formula for specific heat, and remember that the specific heat of water is this value. Next, the specific heat of octane, as formula is given here, is this number. How many joules of heat are needed to raise the temperature of 80 grams of octane from 10C to 25C? Next, the specific heat capacity of lead is this number. How much heat in joules is required to raise the temperature of 15 grams of lead from 22 to 37 degrees Celsius? Next, the specific heat capacity of liquid water is, once again, this value. How many joules of heat are needed to raise the temperature of 5 grams of water from this temperature to that temperature? Alright, that's it. If you can do all of these kinds of problems, you have successfully reviewed and have all of the skills needed to do all of the stuff from chapters 2 through 5 from general chemistry. Please stay tuned to my next set of special topics lecture videos in which I'll begin doing my coverage of chapters 6 through like infinity or something like that. Until then, my wonderful students, have an enjoyable rest of your day.